Okay, this is the going to be my just working out of the algebra of the other one of my mega fave numbers. Again, you can see what what the actual values are. We aren't calculating that in this video. You can see that at the end of the video. Put a link or whatever. Okay, so here we go. This is going to be coming up with a formula similar to this. This was from the last video. Card. So similar to that, just working out of the algebra. First thing we have to define. I suppose I should tell you what we're sorting out. We are calculating the number of songs that are possible. So, what we're really calculating is the number of MIDI files that the humans can differentiate. We're assuming that there can be notes stacked on top of each other, but that you can't have you can have notes stacked on top of each other, but you can't have words. Words are challenging. You can have notes stacked on top of each other, but you can't have multiple timbres. That's just too complicated. I'm not going to bother with that. So there is some number of notes that the human ear can distinguish, on average. And so we're going to call that n for notes, whatever. So n is number of notes that the human ear can distinguish. That's not great handwriting, but you heard what I said, so everything should be good. So number of notes that the human ear can distinguish, and small t, which is going to be the shortest increment of time distinguishable. Now, just to clear this up, this is not the Planck time. That would be insane, which is, in theory, the time quantum. But no, we're not going that insane. No, this is the shortest increment of time distinguishable by the human ear again, but I'm not going to bother writing that out. Then we have big T, which is going to be words again. Words are very challenging. Big T is going to be that's a T. No, big T is the length of the song. So we're just going to be dealing with one length of the song at any given time, for now anyway. Next page or whatever, we'll deal with multiple songs, or multiple lengths of songs. But we have to be able to calculate n, because the number of notes that the human ear can distinguish is hard to look up. So instead, we will have we're going to define an L and let's do little m and big M. Little m and big M for lowest. Well, if we're using little m and big M, we should use minimum frequency, distinguishable by the human ear. This is maximum frequency again. Dittos are useful. And then we will also need to have the the S, whatever. S is the smallest interval. Smallest interval, again, distinguishable by the human ear. That's just kind of a given at this point. So now all of these are going to be different from person to person. So, I mean, like the length of the song isn't, but so all of these, like anything that has to do with human ear is going to be different from person to person. We're just assuming that they're all the same, because, I mean, that's just easier, and yeah. Again, we're not listening to timbre, nothing like that, just a standard, like, I don't know, sine wave MIDI file, piano MIDI file, all the same. Okay, so this is going to be complicated. I have no idea really what I'm doing right now. Let's move the O closer to the F so it looks like it's not length O, it's length of. So we can figure out, let's define O, which is octaves. Smallest interval in cents. There are 100 cents in each of an equal interval. 100 cents each of an equal interval in a semitone. There are 12 semitones in an octave, which means that there are a lot of cents in an octave. 1200, 1200, that should be what it is. Okay, so how many octaves are distinguishable by the human ear? So let's figure out what that is. So it'll have to do with the minimum frequency and the maximum frequency. So we just have to multiply the minimum frequency by 2 over and over until we get the maximum frequency. And there's got to, yes, there is. So it's M Okay, let's define O in a different way. Big M is equal to it's equal to the minimum frequency multiplied by 2 to the O. Okay. Which means, okay, again, this is working out of the algebra, which gives you, okay, divide each side by little m, big M, that kind of looks like a little m, but we'll make sure that the little m looks more like a little m. That equals 2 to the O, which gives you, take a log base 2 of both sides, and then we have O equals log base 2 of M on big M on little m. Okay, so let's plop that down here. O equals log base 2 of big M on little m. Okay. So now we have the number of octaves, but now we need the number of cents. Let's figure out what S is. So, or not. So it's in cents. We need to figure out. We know what S is, or we don't know right now, but we're looking up what S is. So we need to know. So that's the number of notes that the human ear can distinguish. Aha, that's what we need to know. So N is equal to however many octaves there are. So it's gonna be. I need to move that down a bit. Don't quite have enough room. N equals the number of octaves that we can hear divided by The smallest interval we can hear in cents, but we need the same units. Octaves in units of octaves, but the cents are going to be in units of cents. And to convert from cents to octaves, there, oh bother. So O sub O, because that's units, and then S sub C, again units of cents, and we need to multiply that by 1 to change the units. It's just doing dimensional analysis. If you don't know what that is, it doesn't really matter. Look it up. Take chemistry again, whatever class. So we need to cancel out cents because we want it in units of... No, we just want a number. So we need to cancel out octaves and cents. Oh gosh, this is challenging. The number of octaves, which is obviously in units of octaves, and S is in units of cents. Now 1200 cents in an octave. Okay, so we just do 1200 cents per 1 octave, which cancels out all of the units, and you just get 1200. Oh, that doesn't look good. 1200 O on S. Wonderful. Units have cancelled out because O cancels out, boom, boom, and C cancels out. Okay, so now we have S. Shortest English, so that we have shortest increment of time distinguishable, that we look up. Length of the song, that's what we're defining the function in terms of. Minimum frequency and maximum frequency we look up to determine O. S we look up, so I'm gonna put a little star next to the things that we need to look up. That we need to look up. That we need to look up. Maximum, that we need to look up. Smallest interval of time, that we need to look up. And then that we're calculating, that we're calculating. Wonderful. Okay, so now we need to define the function. Now that we have all of the variables that we need to define the function. Okay, this is going to be more challenging. Well... Oh, I just did something similar to this. At each interval of time, or each increment of time, we don't want to use interval too much, that gets complicated. So the shortest increment of time distinguishable. Okay. Well, okay, first of all, let's define a function. F is that? Yes, that's on the screen. That's always good. F of big T, given the length of the song. Okay, so given the length of the song, how many combinations of song are there? So I decided that I need to erase this. So I need more variables, and the variable that I need is this big T in units of this, which I'm going to just do as I'm using big N. So that's big N is the number of it's the number of little t's in big T. There we go. Number of little t's in big T, which is simply how many little t's are in big T. That's just big T divided by little t, provided they're both in the same units. Right, we can just do that, yes? big T over little t is the number of... Oh jeez, I can't brain. Big T per little t is unitless, that's good, but little t per big T is unitless as well, because seconds cancels out, or whatever unit you're using cancels out. So you have t... Oh jeez, this is complicated. Please pardon any of this mess that I'm doing. Big T is the length of the song. Little t is the shortest increment of time distinguishable. So little t is going to be very small, and big T is going to be decent sized. And if you do a decent sized number divided by a little number, you get a bigger number. So it must be big T on little t. That's the kind of logic that I use. It works. Okay, now that we have that, we can do f of t. Or actually, no, we want f of n. Well, no. We want f of t, but we want all of these things to be defined. So f of t equals equals, oh my, this is nuts. This is going to be a massive number. Maybe not as massive as like the number of possible ways that you can range all of the bits and stuff in the universe, but it's still going to be a massive number. So f of t is going to be the sum of all of the different notes, all of the different time increments. We're ignoring ties and stuff because that's just too complicated. But each note. Oh my! I need. Okay, we're getting rid of that again. Wonder how many times I'll get rid of the function, or the declaration of the function, or whatever we call it in math terms, before I actually do anything with it. Okay, so I need another variable. Let's make that s better. There we go. I need another variable, which is going to be... Well, we can figure out what it's defining before we come up with a name for the variable. It is the number of ways that you can make each time increment can be in. Oh geez. So we're just using Z because that's just easier. We're using Z, capital Z. Or lowercase z, doesn't matter, it looks like capital, whatever. Okay, so z is the number of, number of combinations, that's an n, it's the number of combinations of each time increment. That's not a great sentence, but oh well. And so z is equal to number of combinations in each time increment. It's gonna be the sum from, I need a variable that I haven't used yet. Let's use I because it's an incrementer. From I equals 0 to I equals to I equals what did I define what n is? A number of notes the human ear can distinguish. Yes, I did. Up until n. From I equals not up until n. Oh geez, okay. So this is the sum of all of that. And okay, yes. Geez, this is nuts. From I equals naught to I equals n. And n is that number, right? Or that number, or whatever you want. Again with the clock. I equal, okay. So we have this sum that we're taking, and it's just of I choose n. And if you're not familiar with that notation, I went over in a previous video. Card. We'll sort that out. Or you can sort that out by either watching that video or looking it up. It's whatever. Okay. I equals not. Okay. So it's just using this notation, n choose I. Okay. Now I think we are actually ready to move on and actually do this function that we keep writing. So f of t equals, so f of t, given the length of the song in seconds, how many possible combinations are there? Z is the number of combinations of each time increment. Okay. That's not a great sentence still. So we're gonna need to use t, or we're gonna need to use n. Oh my, this is challenging. Okay. We're gonna need to use n, and we're gonna need to use z, at the very least. We're probably gonna need to use some other things, but maybe not. Yeah, maybe we won't, because we use everything else to define these two, so maybe we'll only need to use those. Okay. And probably a summation thing. Oh my. Oh my, this is a bit nuts. Okay. Why can't I brain? I might have to pause the video again and sort out how to brain with it before I move on. But maybe not. Hopefully I won't. We'll see. Oh, that's too much lead. There we go. Okay. F of t. So you have the first time increment, and that has that many combinations. And you have the second. Oh, we don't need a summation thing. It's just z to the power of big N, which is a massive number. Doesn't help that that's already a massive number, and that's already a pretty big number too. Holy crap, that's it. Okay. Well then. Now, okay. I think it's time for the next page. I have this insight so that I can reference all of this previous stuff. So we have, again, is this on the screen? Yes, it is. Okay, we have f of t. And we want this in terms of exclusively the four things that we're actually looking up. And as well as this t thing. So first we're going to put it in, so it's originally it's z to the n. So we'll replace z with the formula for z, which is the sum, that's not a great sigma, oh well, the the sum from I equals 0 to I equals small n, which is again the number of notes that are in that the human ear can distinguish. There we go. So and then we have n choose I. So that's Z. Now for n, which is big T on little t to the power of big T over little t. And with that is equal to, oh wow, oh my, that is equal to, need to define that, okay, open parentheses, sigma I equals 0, because I is just an incrementer, so we don't need to define it, it's an incrementer, end of story. But n, which is going on the top, is defined right there as 1200 times O, all divided by S. I wonder if that's an integer. Probably not. So we have that, and then we have 12. Wait, is it really? No, is it really n choose? Okay, we're going back to this page. Is it really n choose I? Or did I just make that up? I think I might have just made that up. Okay, so I is the incrementer. No, why would it be n choose I? It's probably big N choose I. Number of t in t, great. And this is the number of combinations in each time increment. So we need the number of time increments here. This is big N, which is still an n, but it's a very different variable. Okay. But oh no, but that's still little n. That's still little n. Is that still little n? Yes, that's still little n. But that is big N, which so that's still little n. But that's not 1200 O over S. It's n. Big N choose I. I need bigger parentheses here. I need bigger parentheses. Big N choose I. Big N is T on T, which we're allowed to use. T on T. Oh, but it's just, no, it's T on T, choose I. We're doing this horizontally. T on T, choose I. Close the summation. Jeez, this is a bit insane. Next. Oh my, this is going insane. Okay, next. When we close the summation, let's make this bracket bigger. There we go. Okay. Well, that's not it, because we still need to take it to the power of T on T. T on T. Okay. Okay. But O, which is the octaves, still needs to be defined up there. I think we're using another line for this. F is a big F, really big F, not capital, but a big, like massive kind of big, equals the sum from I equals not up to, so O is log base 2 of big M on little m So we have 1200 log base 2. I don't know if you can see that, it's quite small. Log base 2 of big M on little m. All on S. Squeeze that into the corner. And we're taking the sum of what? Okay, let's extend these so it's clear. I don't know that made it any more clear. I think that just made it ugly. Oh well. And we're taking that of T on T, or big T on little t. Choose I. All to the power of big T on little t. And the choose function, oh my, this is nuts. Well, I don't think I'm going to be able to reduce things at all. So this is going to be good enough. This is good enough, it's good enough. But we want another function, g of t, where this time, instead of t being how high it goes up, we want t to be, instead of having t be the length of the song, we want t to be the maximum length of the song. So it's all of the lengths of songs from no time increments to up until however long this is. So g of t equals oh geez, this is nuts. G of t equals oh my, I don't know if I can do this anymore. It's too much math for one day. But it's fine, everything's fine. Everything's fine. Nothing's the matter. So we have g of t is equal to the sum from I equals 0, or I equals not, up until no, oh, can we use g of t again? No, we're just going to use crap. We're just going to use g of some randomish number, or variable. G of, what's something that we haven't used yet? G of x, there, big X there, g of x, done. So we're going from, oh no, wait. Oh, whatever. I know what I'm doing, sort of. Not really. No, I don't really. So what variables do we need? We need z, right? No, we don't want z. We want big N. From big N equals 0 to x on t, small t, and all of that of f of t, no, big T, not little t, big T, not little t, small mix up, t, that's how you draw a big T. There we go. Okay, wonderful. Here's the two formulas. See you in the next video. It'll be somewhere on the screen for whatever the next thing is. I can't even remember anymore. It'll be a card, an end screen thing, I don't know, whatever. You'll see it. Okay, done.